Here is an interesting question. This is the equation of this ellipse. This is the equation of ellipse. And you have 2 points. A is on the ellipse. B is not. And through point B, it draws a straight line, not passing A, intersecting the ellipse at point B and then point Q. So we have 2 lines, AP and AQ. Prove that the slope of AP plus the slope of AQ is a constant. Slope of AP plus slope of AQ is a constant. But slope, some textbooks is called gradient. The same thing. Okay. Proof. We let the slope of a PQ be K. Okay, we let this straight line, which is passing through B, not A, intersecting the ellipse at PQ. This is a straight line. The slope is K. Therefore, knowing K and B, you can find the equation of the line. This is the equation of the line, right? Y minus -1 is equal to the slope times x minus 2. Then you get this. Well, I call this equation number 1. Okay, very good. Now, this is the equation of the line. This is the equation of the ellipse. This is the equation of a line. This is the equation of the ellipse. When we solve this simultaneous equation by get rid of the y, substitute y squared there, you get this equation. So that is the equation of, this will be equation of an intersecting points of the line and the ellipse. So this is the equation, I'll repeat again, of the intersecting point of the ellipse and the line, which means P and Q, right? So that is the equation for the coordinate of a P and a Q. Yeah, I call this equation 2. Since P and Q are on the ellipse, therefore x1 and x2 are solutions. Right? x2 and x1 is 2 solutions to this equation. Now, do you know this? This is a quadratic. This is a quadratic equation, and we divide by a, we get x squared plus b over a, x plus c over a is equal to 0, right? If alpha and beta are solutions of this equation, quadratic equation, then x minus alpha multiplied by x times beta is equal to 0, right? Because these two solutions. So you have x squared minus alpha plus beta x plus alpha beta is equal to 0. Okay, which means that alpha plus beta will be equal to negative b over a, right? And alpha times beta is equal to c over a. Right? That is the relation between the solutions and the coefficients of the equation. Well, sometimes we call it what? Vieta theorem, right? So, okay. Now, since x1, x2 are the solutions to this equation. Why? Because x2 and x1 are on the line, right? On the straight line. This is this is the equation of the points on both ellipse and the straight line. Okay, then using this, the summation of two solutions is negative b over a. The product of two solutions equal to c over a. Therefore, the summation of the two solutions is negative b over a. This is a b, right? This is a b, this is a. And the product of the two solutions is c over a. This is c, this is a. Right? Now, we suppose that the gradient, the slopes of AP, is y1 minus 1, right? Over x1 minus 0. That is this. And the slopes of AQ is y2 minus 1 over x2 minus 0. That is this. Therefore, the summation of these two solutions, now the summation of these two slopes is this plus this. This is slope 1, this is slope 2. And by using formula equation 1, we can get rid of y, because y is equal to this, right? For the points on the line. And then this equation becomes this expression rather is this expression is this, because x1, x2, y1, y2 is on the line. Then then we simplify these two fractions, become this. Well, I omitted these detailed calculations, just simple algebra. And then by substitute x1 plus x2 is this. x1 times x2 is this. So this substitute for that, this substitute for this, then we calculate, we get negative 1. So which means the sum of slopes of AP plus AQ is negative 1, which is a constant. Well, I simply omit these algebraic calculations, but if if you follow what I've explained, should be very clear that the proof has been done. The sum of the slopes is equal to -1. Thank you for your watching.